I try to be very brief in my talk. I will talk about the possibility of seeing nullity as a special kind of set, a set that I name as sets in superposition. The name comes from quantum mechanics, idea that I think that has analogies in quantum mechanics, but the sense of this expression for me is priorly logic, is logical. The expression has a logical sense. So what I talk is the following. Let's consider a language, logical language, in which you have all the syntactical terms as terms for predicates, terms for variables, terms for logical symbols, quantifiers, propositional operators, etc., and terms for constants. In this last class of constants, you must have two kinds of constants: the usual constants that point for a unique object, and constants that has a extravagance property. Such constants point for more than one object at the same time. So the idea is the following. In such language, you can construct equations that has as solution sets or ordinary sets, or you have as solutions sets in superposition. I will type some formula on chat. I think that is such a way that the things becomes clearer. So you have in this language the possibility of having an equation like that. Excuse me. It has if the language is interpreted in real numbers, the solution of this set is all real numbers. All real numbers has formed the set made by X.
Can I just say that, sorry, Walter, can I just say that Walter is typing into the chat, so you might want to watch your chats. Carry on.
Yeah. Can you see the typing?
Yeah, no problem.
Yes. So in such language, you have another possibility for expressing this equation. You must have something like that. Excuse me. That is. So in this case, this C with this asterisk as a superindex is not more a variable, but is a constant. I call this type of constant equivocal constants. It seems like a paradox in terms. This is a constant. How can I be equivocal? But the idea is that one. So you have an equivocal constant. So C with this asterisk is a equivocal constant, and you can interpret it as a set in superposition. I don't know how to define the set in a precision way. I'm just thinking about this. For instance, is just an idea. Setting in superposition. Excuse me for the strange kind of typing. The set in superposition. So you have equations that implies that generate the sets, ordinary sets, an equation that generate the set in superposition. What is the difference between an ordinary set and a set in superposition. A set in superposition works as a name, not as a set. It's something very similar to a name, but this name points for all numbers, all objects at the same time. It's something that if you are considering philosophical speculations about it, it seems very strange because name works as a demonstrative pronoun, this, that. So it's very strange to postulate a name that has at the same time, that points at the same time to many objects. But I think that this idea is not very strange because now is a philosophical consideration that I will make. In set theory, especially in counter set theory, you have the notion of all ordinals, the sequence of all ordinals, the sequence of all cardinal numbers, and counter there is a lot of correspondence between counter in some mathematics, in some mathematicians, in which counter said that the sequence of all ordinals and the sequence of all cardinals are not a set, but has unity. Such sequence cannot be considered as set, but can be considered as something that has unity. So why not postulate that Cantor was talking about sets in superposition? I said again that I don't have any kind of algebra or any kind of logical tools that defines in a precise way what are sets in superposition. But I think that there are some contests, especially in philosophical thought, in mathematics, in which you can see some kind of sets in superposition. Let me give an example. In such example, I will show a doubt that I have about how mathematical terms works. If I consider in calculus, integral calculus, the situation that I must integrate some function that is a derivative, something like that. So I put this term inside integrando, that is the name, I don't know, integrando. So the result is something like that. You have a function, the primitive function plus a constant. So now it's a doubt that I have. What is such constant under a logical perspective? This constant is not a constant, but this constant is not a set. There's no meaning in this expression replace this constant by a set, something like that, where R means the real numbers. I know intuitively that this constant points to all real numbers at the same time. And if I consider a special number x0, this constant becomes a determinate real number. I think it's very basic in calculus. But if I consider the equation of the first expression inside the integrando, and this expression in which I have such constant, I don't know what is the logical meaning of such constants. That's not I'm talking about a true doubt of mine. I don't know what this constant is. So if someone can help about this, I will be very, for me, it will be very interesting. So I was thinking about that in such context, this constant of integration could be seen as something similar to a set in superposition. So what about this? Why not consider that in this case, in this equation where I have 0 plus c asterisk equals 0, what about z asterisk means a set in superpositions, something that works in some sense as a set, but is not an ordinary set. It's a set in which all terms must be considered at the same time. So a set in superposition cannot be present as a list as a list of elements. A set in superposition is something more similar as a name. Metaphysically, I think that this nullity, especially nullity, is a very interesting way to represent some properties of God. Nullity for me is a metaphysical number, but if nullity is a metaphysical number, I must change my logical categories to insert nullity inside it. So that is the idea. I don't think, as I said before, this idea is still very undeveloped. I don't know if this is the word in English. This idea must be developed in a more logical way, but the insight is that, and I thought that in this conference, Transmathematica Conference was a good opportunity to share this idea with you. So so the basic idea is that one. I don't know. I have more to say. I think.
Okay, thank you. Let me kick off. So you asked what is the nature of C in your formula f of x plus c.
Yes.
And it strikes me that the difficulty you have is related to an issue that Jan raised earlier, where a fract term is the written form of a fraction, and the fraction evaluates to something. So your doubt was, what is C? Now, in the formula f of x plus c, c is a variable. You can replace it with any real number. In the integral, c, in any specific integral, c is a constant. So c plays two roles. In the formula is a variable, but in the integral it's a constant. In exactly the same way that a fract term is a written form of a fraction, and the number is a fraction. So I hope that answers one of your questions.
I must emphasize that I'm asking about the logical rule of C, because if C was a variable, when I made the integral, C will change. C will transform his aspect. So everybody knows intuitively that C points to all real numbers at the same time. If I have a formula like that.
Yeah, I think that means that C is a variable.
Yeah, but not a variable in the usual sense, because C points to all numbers at the same time. C becomes a determinate number when I make some calculus. So yeah. If I specify x0, you put in the integrando, I have 0 equals f x0 plus z. So z will be minus f x0. So the negative value of the function at x0.
Imagine I was solving a quadratic equation written in terms of x squared, x and some constant. Then the x is a variable, and the variable can take on two values, maybe two real values, whatever. So I think it's in the nature of a variable that it can take on different answers in the solution set. And indeed, we have in mathematics, we have the idea of a solution set.
Well, yes.
So I'm not sure what new idea you're getting at.
Yeah, if I consider an equation of something like that. this equation is nothing. I can consider this equation in this perspective. I want to show in two ways. X is a variable, so the solution of this equation is a set made compound by -2 and 2.
So
But if I
sorry,
consider,
you've written X, I think what you mean is x squared equals 4.
yeah, x squared, excuse me, this x squared. Here, my knowledge about typing is very limited.
Yeah, all right.
So x squared equals to 4. So the set solution is that one. There is a type in here, a typo, but I think this is very clear what I'm trying to say. -2, the set compounds by -2 and 2. If X is a set in superposition, something like that. Now I have the following situation. The solution is not a normal set, it's a set in superposition. So the constant C asterisk points to -2 in 2 at the same time. Every set in some way you have a list. So every set every element of a set must be considered in some kind of temporal sequence. There is a temporality by which I can analyze a set. If I consider a set in superposition, this number must be considered at the same time. So I have a name, a compounded name that is the solution of such expression. So for me, it's such logical range in which you have this equivocal constant. Nullity will be an equivocal constant that points to all real numbers. If I consider that nullity comes from such equation like that. Nullity will be every real numbers at the same time, and not the set of real numbers. It's something that I am consider that I can make a perpendicular rotation in a set. You have a set, you have a set in superposition. It must be considered at the same time. All elements of a set must be considered at the same time. As I know before, as I told before, this idea is still very imprecise, but the basic insight about it is that one that I'm talking about. Is what I'm told here. So, Thiago, do you have do you can aid me about this constant C? What is this constancy? In a logical perspective.
I am thinking about your work. You see nullity as in some kind, nullity as a superposition of all real numbers. And in my construction, nullity is the set of all hyperreal numbers. And do you see any relation between our work, your work and my work? How you see this relation? Because of course you see as all real numbers, and I see nullity as the set of hyperreal numbers, but I think it's similar. What do you think about it?
What is the difference? You are considering nullity as a set. In a logical term, set must be translated into a logical language as a constant for predicates. The set is the extension aspect of some property. And properties must be put into logical language as predicates, relations, predicates. My consideration takes on account that the nullity is a name, a constant, not a set. I know that every set has a name, but I can consider names that must be not usual names. That's why I think that the nullity, when one considers nullity, we must have in mind that the usual logical categories for dealing with nullity are not enough, are not sufficient to grasp all possibilities that nullity has. So that's the idea. You must expand our logical language. In such expanded logical language, you put nullity without doing, I don't know what the term is, without doing so many calculus about nullity. Nullity now is another logical category. So I think if you consider that a C is an equivocal name, everything I do with C must be an equivocal name. C plus one, C, because you have in the realm of some kind of indeterminate. Although this indeterminacy is not absolute, you have a spectrum in which this indeterminacy varies.
So would you assume that C star is equal to C star?
Yes, you must have this identity.
Oh,
C is a name. If you are consider this equation as usual, you must have just a identity between names. So now is a name, and I must distinguish between the name and the objects that name points, that are the references of the name.
mhm.
So nullity will be the name that points at the same time for all real numbers. I must amplify such definition and consider nullity as the name of all hyperreal numbers. But I think that the original context in which nullity comes is about talking on real numbers. This impossibility of doing 0 over 0 is the source of nullity. I don't know, James will agree with me, but so why not consider such possibility of having expanded logical language in which nullity enter as a special kind of new category of logic concept, of logical term.
I have a question. How does a name differ from a set?
A name, a set must a set admits to be present as a list, as an enlistment. I don't know, a list. A name is a way to point to objects in a more direct way. Excuse me.
Okay, so I can imagine writing something like X is equal to the set, blah, blah. And I think X is then the name of the set. Is that right?
Yeah, but if you have a logical language, you have in such language two kinds of names: the predicates and names, singles, A, B, C, D. The idea is consider the stock of names of constants in split such classes of names in two kinds of sets, two kinds of classes. The classes of names that point to one name to one name, to just one object, usual names, and the names that can be associated to more than one object, equivocal names. If I have name is considered in logical thought as a function. Name rules works as a function. Equivocal constants, no. The name could be can be associated to many objects at the same time. It's very similar to the word when we are studying metaphysics. You must consider the expression being. Being is not a set. What is the set associated to being? You cannot consider being as a set because being has no complements. Not being. Not being is what is not being. So being must be a name, metaphysical name. I don't know, in English you have the expression being. In Portuguese you can use the expression ser. I don't know if there is any difference in English and in Portuguese. So you have such kind of circumstance that's not easy to deal with the usual logical vocabulary. What is being? Is a set? Is a name? I don't know, but I know that everything is being, but not in the meaning of a set. If I consider being a set, I must put everything inside the set, including the set. The set being will be inside the being, but you have no logical possibilities of close the set as a set. But for me, it's very easy to use such expression as a name, the being, as a unity, substantial unity that must be different from a set.
So can you solve equations with these things that you could not solve otherwise?
Excuse me, I didn't understand you. Can you talk again, please?
Does this help you to solve equations that cannot be solved otherwise?
Yeah, I think I can solve some metaphysical paradoxes, but in math, specifically in mathematics, I just have some ideas. One of them is if I was in the every term when I use a term in a specific theory, mathematical theory, can I classify such terms in a very precise logical way? If I have the usual logic building on Aristotle, Toff, Frege, or mathematical terms are more complex than such categories. I don't know if I consider the imaginary numbers, the unity I, the complex imaginary numbers. They are named, they are sets, but I don't know if the concept of a number must be put could be put in the concept of set. I don't know if number must be considered as names or as names, just names, not sets. If from such names I must construct sets.
Mm-hmm.
That's the idea. I don't. So just to by conclude, I would say that there must be a logical language, amplified logical language, in which you insert equivocal names. Such equivocal names works as nullity, or nullity works as equivocal names. If I consider equations of time of this kind, 0 times c asterisk equals 0. If I consider c as a usual variable, the answer for the solution for such equation is a set, the set of real numbers. Yeah, but I have the option to consider c asterisk as a constant, equivocal constant. So c will be a name or a set in superposition. every real number must be considered at the same time. And it must be considered at the same time, and in the radical sense that you cannot put the real numbers as a list, as an enlistment, as a sequence in a list. They must be considered in a vertical way, not in the horizontal. So that is the idea.
Walter, in your work about total semantics, you consider nullity as the indeterminate value, the semantic value of indeterminate propositions. Are there any relations, or is there any relation between the semantic value of indeterminate in logical semantics and you're thinking about nullity as the superposition of all real numbers?
I don't know. I think that they are independent. I don't know, because this idea of setting superposition is very associated to the idea of the why I cannot have the expression 0/0 in real numbers. So I come from real numbers and postulate a new kind of number. So I will achieve the transreal domain from real numbers. I amplify the language to achieve transreal numbers. In total semantics, I think that there is a different context. We are considering all logical possibilities, including the indeterminacy.
Okay.